I'm Rajaman Rai. I am an assistant professor of biomedical informatics here at Harvard Medical School, and I'm delighted to be organizing this meeting this year along with Professor Kohani. I want to welcome you all, both in person and online, to our meeting. This is our 9th annual Precision Medicine meeting, and this year we're focused on the intersection of precision medicine and global health. So this is, we've been running this conference for almost a decade, and every year we like to begin with a patient keynote. This is often remarkable patients or caregivers who've not only navigated the health system, but they've also launched scientific and industry initiatives or even moved market forces to address unmet needs. This year is no exception. It's my distinct pleasure to introduce our opening keynote speaker, Krystal Birungi. Krystal is an entomologist at the Uganda Virus Research Institute. She survived malaria as a child, and now she fights the disease every day with cutting-edge scientific techniques that she'll tell you about on the front lines of the Target Malaria Initiative in Uganda. Welcome, Krystal.
Hi, good morning, everyone. My name is Krystal Birungi. I've been introduced. I'm an entomologist from Uganda, and it's really an honor to be standing before you today. So as we get started, would you please turn your attention to the video?
My little brother was 5, and he was convulsing. My mother used to work, but she had to make a decision. Should I stay at home and, keep this child cool so that they don't die, or do I go out and make the money that I need to buy the medication? My name is Krystal Birungi, and I am fighting to end malaria in Uganda. I am an entomologist. Studying mosquitoes is very important. Most of my work is in a project called Target Malaria to reduce mosquito populations, thereby interrupting malaria transmission. What it means when you save the life of a young child is that you save the future of a nation. I fight for what counts because every child, regardless of where they come from, should be protected from malaria.
So, allow me to reintroduce myself. My name is Krystal Birungi, and I'm a malaria survivor from Uganda. Growing up, this disease almost killed me multiple times, as well as my brothers. However, we were the lucky ones because we survived. And today, I'm still not immune. Malaria kills over 600,000 people around the world, and over 90% of those deaths happen in Africa. My country, Uganda, is one of the top 5 countries contributing to that malaria burden. And most of the people that die from malaria are pregnant mothers and children under the age of 5. In fact, in Uganda, malaria is the leading cause of death in children under the age of 5. I am a mother, and my child, not yet 5 years old. So I think we can all agree that I do not lack motivation to eliminate this disease. And growing up, looking at all the suffering that this disease causes, this preventable, curable disease, is what has inspired me to do what I do today. It is why I'm an entomologist, trying to find ways to eliminate the mosquitoes that spread malaria. And it is why today I stand in front of you in a unique position, where I'm both the community that is living with this problem and the community that is innovating to solve this problem. There is power in having the people that are most affected by a disease fighting the disease, because nobody is more motivated. Now, we have a lot of tools in place to fight malaria, so we don't have nothing. But the truth is that there's also a lot of challenges, and the key challenges facing malaria elimination is basically insecticide resistance and drug resistance to the existing tools. The other problem is funding. So that lovely video you watched was actually filmed by the Global Fund, an organization that's raising billions to control malaria, among other diseases. But the funding gap remains clear. It's just not enough. We're still losing a child a minute to malaria. So we need more. We need more tools. We need more innovation. And that is where Target Malaria comes in. So Target Malaria is an international consortium. We're a not-for-profit research company, well, organization, I guess. And we have collaboration between scientists, between regulatory experts, between stakeholder engagement experts. So it's a lot of people working together trying to eliminate this problem. We have teams from all around the world, from 3 continents, Africa, Europe, and North America. So we want to see a world that is free of malaria. And to do that, we commit to developing new technology that's genetically based and want it to be sustainable. And we think that modifying mosquitoes to control the mosquitoes that spread malaria, thereby interrupting transmission, is how we will get there. We're committed to making sure that we have excellence in our research and that it's co-developed with the people that need it the most. We're not shoving it down anybody's throats. We commit to having it evidence-driven. So we will have research that shows that it works before it's ever used. And we will be open and accountable to everybody that is both receiving this and to everybody that's regulating it. It is a pretty big organization. We have close to 200 experts coming from all across the world. But what is really special about Target Malaria is that we include implementing countries, countries where the problem is. So we have scientists, researchers, stakeholder engagement experts, as well as regulatory experts from all these different countries involved as well. So in Uganda at the moment, that is one of the things that we particularly value coming from the Uganda Virus Research Institute. But we also have partners in Burkina Faso, in Ouagadougou, as well as in Accra, Ghana, and of course, where I'm from. And as you can see, we're still saying we have 13 million malaria infection cases in 2021. So the problem is real for us. So what is Target Malaria doing? Well, first, the basics is when we're looking at genes and genetic modification. So we have over 3,500 species of mosquitoes in the world. And of those, about only 40 species or so are known to transmit malaria or have the ability to transmit malaria. So the beauty of when you're working with genetics is that you can be super specific. Because out of all those 40 plus species or so, only 3 actually are responsible for practically all of the malaria transmission in Africa. And that is Anopheles gambiae, Anopheles colutzai, and Anopheles arabiensis. So Target Malaria is focusing on these 3 species first. We think that if we can reduce the numbers of these species, then we can possibly interrupt transmission and therefore have a big impact on malaria rates in Africa. So, what do we think about using genetics to control mosquitoes? So there are a few traits you can pick that would work for you. That includes everything from resistance to malaria, inability to bite, or affecting their fertility. So maybe they cannot reproduce, or you have mostly male mosquitoes. So male mosquitoes do not bite, so they do not spread malaria. But also, if you have more male mosquitoes, inevitably, you are going to have a population reduction at some point, because there's just less females to reproduce. Now, the challenge, when you have new genes in a population, either through mutation or even if you insert one, they tend to stick around in only very low numbers. And if they're deleterious to the species, they're even more likely to get wiped out pretty fast. So that is one of the biggest challenges when you're looking at having genetic modification, which relies on the gene being passed down in order to have an impact. So how do we do it? Well, basically, it's not that complicated. We have a plasmid DNA with the transgene, and that's injected into the mosquito embryos. So those injected adults are then crossed with wild-type mosquitoes, or like the existing populations from the field sites. And then you can see whether or not your offspring are transgenic using a fluorescent marker. And we can see that in the larvae. But adults are then, the genetically modified adults are what would be your final tool. So, dealing with that challenge of the fact that your modification may not stick around too much. It's how we get finally to what's special about what Target Malaria does, which is gene drive for vector control. So what exactly is gene drive? When you have your inheritance of genes, usually you will have about half the time these genes being inherited if you use Mendelian inheritance. So the difference is that with gene drives, the genes are always inherited. So that's what we're calling a driving gene, or why it's called gene drive. So basically, over 90% of your progeny would have this gene that you inserted. And basically what that means is you don't need as many generations to achieve the kind of numbers that would make an impact or make a difference, making it a bit more cost-effective and sustainable. So basically, we use the DNA cutting enzymes, nucleases, to modify the mosquito genes in a very precise way. So the nucleus is then what we use to make the genes drive, like I just described. So Target Malaria has two kind of approaches that we're thinking about at the moment. So there is female fertility, where we would have it affecting the female's ability to reproduce over time. Or we have male biasing. So basically, during gamete formation, the X chromosome would be destroyed, so that you only have male progeny, ideally. So what that means is that we're going to go ahead and have this modification increased throughout the generations as it's spreading. So having a few individuals with your gene drive can basically spread the modification throughout your population quite effectively. So whether or not we're looking at female fertility, where you have homozygous females be infertile, or if we're looking at male bias, where you have over 90% of eggs laid actually hatching to be male, the end point remains the same. We can control malaria-spreading mosquitoes. So we can eliminate malaria. Now, what is special about gene drive? There are a few key elements. One, we hope that it will be long-term and compatible to all other existing tools. It has been pretty clear over the years and with all the research that's been available that we're not going to eliminate malaria with one tool. One of the biggest impacts on malaria actually has been integrated vector control management. So different things all coming together to control mosquitoes that spread malaria. So this tool would be compatible to the existing interventions. You don't have to remove one for this to work. There is no cross-resistance with other interventions. So because you have insecticide resistance doesn't mean that this tool cannot work. It's sustainable because we're basically asking mosquitoes to control mosquitoes over generations. So it's a little bit more sustainable than, say, if you had sterile male releases, because that means you have to have multiple releases to affect a large population in the field. But also, you don't need to have a strong health system for this because, well, it's not really part of it, is it? You just go and release mosquitoes. So the health system, whether a country has it or not, doesn't affect the effectiveness of the method. But also whether a region is stable or unstable, mosquitoes fly, you can just release it where you can actually access. So there's a lot of really useful characteristics to using a gene drive, as well as the cost-effective element, because long-term, if you need fewer releases, it should cost you less money to do this. And there is no need for people to behave a certain way to be able to use them correctly. Because as we know, one of the challenges of the existing methods is just the use of them. So if you have mosquito nets, but people are using them to fish, for example, they're not doing their job. If you have vaccines, but people will not bring their children to be vaccinated, they're not doing their job. So those are some of the really key features of a gene drive that's very, very, very useful. However, on the road to having a gene drive tool, there is a very key element of testing gene drive mosquitoes. And that's always going to be a challenge when you have innovative technology that's new that people don't really know a lot about. So Target Malaria's approach is built on 3 pillars, and that is science, stakeholder engagement, and regulatory affairs. So we have a phased technology development. So we're not just waiting to get to our final product and say, hey, here it is, use it. Because we've seen multiple problems that come from that scenario. So with that in mind, we had the first phase, which was the sterile male mosquitoes. So this was a genetically modified mosquito that was sterile. So it could not pass down anything to the next generation. So no offspring, no significant impact on population, for various reasons, of course. If it's a modified mosquito, not as fit as the wild type population. If populations are big, it's one release or a few releases is really not going to have a particular impact on that population. However, that mosquito was great for capacity building. It allowed us to show for the first time ever that you could import a genetically modified mosquito into Africa. It allowed capacity building of regulators, because this work is all very heavily regulated. We cannot work without regulation in place and without approvals. It allowed the teams to get capacity building within Africa of handling genetically modified mosquitoes. So for various reasons, technology, resources and all the things that we need, the development of the mosquitoes does not happen in the African countries. It's actually happening in Italy, it's happening in Imperial College of London. So, and also because obviously if you have, say, an escape in Italy, it's less likely that it will be a huge disaster because the environment is just not very good for mosquitoes. They have winter and things like that. So of course we have very stringent containment protocols, so that's not likely to happen. But for various reasons, the actual technology development is off-site. So that means that you need to have some kind of genetically modified mosquitoes for the insectaries in the African countries to actually get some experience handling this and to really be able to say that they are competent and they have had capacity built. So the sterile male mosquito was great for that. It was imported into Burkina Faso fast, and they did containment lab studies and releases. And we also had it imported into Mali as well. So all of these countries, including Uganda, have world-class arthropod containment level 2 insectaries, which is the WHO recommended level for handling genetically modified mosquitoes. After sterile male, we had the male bias or male bias modified mosquito. So that is genetically modified, but it is fertile. So we expect that it will pass down the modification to its offspring. However, it does not have a gene drive. So that means inheritance is by Mendelian processes, which means we don't expect it to also persist very long. There might be a transient impact on the population for just a short time, but because it doesn't have a gene drive, it is really not the final tool. So this is also being used for capacity building. And basically, as well as testing shipping mechanisms, do the mosquitoes get there alive? How long do they take? You know, how efficient is the process? So that has been imported into Burkina Faso. And Uganda has also submitted the regulatory dossier, which is to the regulators to approve this work also happening in Uganda. So that is currently at contained studies, so within the contained laboratories. Our final product in this phase development will be a gene drive mosquito. So either male bias or female fertility that we expect to then have that sustainable impact on malaria mosquito numbers, thereby interrupting malaria transmission. So, well, this slide is basically what I just talked about, but it's talking about what we've currently done. So Burkina Faso, we did the sterile male, and now they're doing contained studies of the male bias. And then Uganda is still waiting to receive the mosquitoes or complete approvals and then receive mosquitoes and do the same. In Ghana, which is another partner we have, they are doing ecological and rearing studies. So when you're looking at anything like this, it's going to be in the environment. We know and expect that there'll be a lot of questions, like what happens to the environment when you release it? What about animals that feed on it? So there's a lot of different questions that people are going to have. So the Ghana team is focused almost exclusively on that. They're looking at the food web, they're looking at what exists within the breeding pools with anopheles, and what does it mean when you take that out? What is a probable pathway to harm of having genetically modified mosquitoes in the environment? Yes, so the gene drive mosquito, our final or projected final technology, is actually still in development in the lab, and is being tested in small and large cages in Tierney, in Italy. So one very important arm that honestly we really have to think about when you're looking at innovative technology, anything that's new that people don't really understand, is regulatory affairs. So we know that regulators are really, really important. So with anything new, when you're looking at technology like this, we look at, once you make your discovery, there are a few key elements on the path to implementing this technology. First, Does it work? So that part is a little bit easier, right? Because you do your studies, you go to the field. There is a lot of regulatory framework in place for that. But something that I think scientists often miss is that, is it acceptable? So you go, you work really hard, you develop this new innovative technology, and then when you want to use it, people say, oh, hell no, they're trying to make us sterile. Or, this is just evil corporations trying to make money in some weird way we don't understand. So it's very important to think about public acceptance. And also what kind of impact you're going to have on everything else, economically, environmentally, because these are all possible challenges that will come up in the future of your technology. Then the last thing is implementation. So how do you plan to deliver this technology? Is it actually technology that can work in the field? Or do you have some lovely thing that, I'll give you a really good example. We had COVID-19, right? There were some wonderful vaccines that were developed that required to be kept at, what temperature was that? Really, really low temperatures, or mRNA vaccines. And then you want to deploy them in Africa to remote villages where electricity, not a thing. So there are certain things that we have to think about when you're thinking about that. So what are your delivery plans? Are you going to have portable freezers or something like that? So it depends on what your technology is, but you have to think about, can you actually deliver it? And then when you do try to deliver it, will the public let you? So there's really an important element of ongoing public engagement if you really want to make sure that you can deliver your new tool. So for gene drive, what does that mean? Well, it's new. It's very new. When we say it's novel, like it's not been, there's been no gene drive mosquitoes released anywhere in the world, including by Target Malaria. We haven't had any releases happening yet. Luckily, research can be undertaken within existing regulatory framework. So there is framework for doing the research, even if not for implementation at the moment. So there's been, the processes that regulators need to follow to assess it are well defined, but there is no precedent for gene drive. No one has regulated it before. So it's really important to consider the capacity building that the regulators need. For example, so Target Malaria is a research consortium working on developing the mosquitoes, but we're also concerned about the regulators that are going to be in charge of approving this. Do they have the capacity to do that? And what can we do to support that, to make sure that when we get there, we actually have a regulatory framework in place that can reliably regulate this. So another challenge we really have is that not all countries have adopted those national frameworks for genetically modified mosquitoes. So there's a number of most countries that just don't have anything at all. And that is why a phased program development is so beneficial for us, because it means it gives regulators time to have some experience with at least genetically modified organisms, to feel confident that they can do this, and also for their countries to be confident about this. So right now, gene drives in development are regulated just as genetically modified mosquitoes, no different from that. But it will be really a case-by-case assessment, depending on the product characteristics in the future, and not the regulation of underlying molecular technology, which is also very important, because if they just ban everything or there's just one regulation that doesn't fit all, that can really be a challenge. So at the core of it is building the public trust and ensuring safety. Because if you don't have that, then you're going to have a lot of regulatory roadblocks. And that depends on guidance from regional and international levels, as well as the national laws and regulations of each of the countries that we're actually involved in, as well as, of course, internationally binding agreements. So for Target Malaria, in every country that we're actually working in, it is a requirement that those countries must have national regulatory frameworks that can actually review applications for work like this. And each of those countries has its own framework, and the project regularly engages with those national regulatory bodies, both in an information sharing capacity, and also in just making sure that we know what we need to do and meet all the requirements for us. So in some countries, those biosafety regulators fall under different ministries. In some countries, we work with environmental ministries as well, because there is an issue of impact assessments for the environment and so on. We also have support for those regulators. There are organizations that do that. For example, NEPAD, which is the African Union technical arm that's really doing something about regulatory oversight when it comes to genetically modified organisms. Now, one other very key arm for us is the stakeholder engagement arm. So, stakeholder engagement is just basically building trust, having people trust you, and having a good relationship with the communities that are going to receive this technology over time. Because something like Target Malaria, which is a very long-lived project from discovery to actually having a technology that you can implement, it's something that requires a very good long-term relationship with stakeholders. So there's a number of ways to do that, from information sharing to negotiation partnerships. There's a lot of ways that you can make sure that your stakeholders are on board with what you're doing. However, gene-drive research does have some key elements that make it a little bit different from regular stakeholder engagement. The first thing is that it's an environmental intervention. The mosquitoes are going to be in the environment, and that is always going to add a layer of complication to the stakeholders that you have to talk to, because of course there's a lot of environmental concerns as well. But also key is that individuals cannot simply opt out. You can't say, oh, in my backyard or in my compound, I don't want any gene-drive mosquitoes. Let my neighbor have them, because they fly. They don't care if you want them there or not. So there is an added element of complication to stakeholder engagement, in that you have to have a higher approval rating than you would for some technologies that are super, only apply to this one person, because the mosquitoes do not respect international borders, for example. So Uganda says yes, Kenya says no, what happens? So that means that your engagement is going to cover a much wider field. The last thing is that research progress cannot, you can't really tangibly see it. It can be considered intangible. So when you're looking at the local population, say the villages where this technology is going to be deployed, because they matter too. They're basically the recipients of this technology. And you're going to engage them today and tell them, oh, this is Target Malaria, we're collecting your mosquitoes from your houses and we're going to study them because we need that to develop this genetically modified mosquito that's going to do ABC. And you do that today, and tomorrow, and next year, and the year after that. Target Malaria in Uganda started in 2013. We are in 2023, 10 years later, and we still have not deployed this mosquito. So to the regular person, they're like, so what have you been doing for 10 years? Like, what is it? They feel like we've done nothing. But we know we've done a lot, but they can't see it. So when you're trying to have this long-term trust and build this relationship, and it's been 10 years, research seems a little intangible to them. So you need to think about how you're going to do that, and what kind of tools you're going to have in place to make sure that they're still with you after all this time. So Target Malaria has a multi-layered strategy. Of course, I've talked about the different stakeholder engagement groups, because you need different levels of acceptance. And each of those requires a different strategy and degree of engagement. So for example, what you do at an international level, you're looking at the COP23, for example. At some point, someone was suggesting a moratorium on gene drive. So that would be a disaster, right? Because then you can't deploy it anywhere. So you need to be at that level, but you also need to be at the African regional level, because like I said, the mosquitoes fly. So it doesn't matter if a couple of countries say yes, and then all the countries around them say no, then you still have a problem. But we also have the local level, so the government regulators, and even before that, all the different levels they have within that, right down to the final person that says, malaria sucks, just kill all the mosquitoes. Because actually, that's what happens, isn't it? The people who are most affected don't care that much about all your other issues. They just want it gone. But we can't look at just that when you're looking at regulatory issues. So yes, we do look at all of that, and we have different techniques in place for engaging all those different levels. It's going to take collaboration between regulators, scientists, and stakeholders if we ever want to get novel technology to the people that need it most. It doesn't matter if the people you're trying to help are only, say, 100, and their voices are just too low to be heard. Or if, like in the case of malaria, there are millions, but their lack of a platform means that what should be a roar is really only a whisper. Every single one matters. Every life matters. I am here today because someone did the research that was required to develop the initial tools to combat malaria. And because somebody else funded it for a community that would never have been able to afford this. And now every day, I try to save lives. What you do matters. You cannot put a price on human life. Thank you.
All right. Thank you so much, Krystal. That was fantastic. So we'll invite anyone in here in the in-person audience to come to the microphones to ask questions. And if you're in the online audience, you can pose the questions in the chat. I will maybe just get us started while we're waiting for folks to line up. Krystal, you can feel free to reject the premise of this question. I almost hope you do. But how do you navigate the tension between high-tech precision interventions like what you showed versus low-tech preventative measures? So stated another way, what would you say to those who argue we need more bed nets and fewer gene drives?
Yes, that is unsurprisingly a question that actually we get quite a bit. So I think the key thing is that it's not either or. Like, bed nets have done a lot, but there's clear evidence that progress against malaria is just stalling. We're losing a child a minute. So my question, I'll just ask them another question and say, is it worth it to be so afraid of change that we let children die? Like, is it? Why can't we work together? We need as many tools as we can to eliminate this deadly disease.
Hi, Zach Kohane. My question is, if you were meeting your younger self about to do this, what would you say to yourself that you should do differently at the beginning?
What would I say to do differently at the beginning? I think that if I was talking to my younger self, asking myself, well, what have I seen over the years that I'll do differently? I feel like really not much. I really, really like where I ended up. Like, I'm very passionate about malaria elimination. Today, I still see families that really suffer from this. And having that kind of experience growing up, it pains me that all these years later, there's still parents deciding how many children to have based on the fact that some of them will die from malaria. This is not something that should be acceptable. They shouldn't be used to this. But that's just what it is. So if we can make a difference this way, I mean, why not? So I think I'm pretty happy with where I am. I wish it could be done faster, but I'm aware of the intricacies of that. So yeah, I'm not much. Yeah.
Well, that's an enviable position, and I just want to say that people don't understand how close we are to that experience that you talked about, and how war actually can change things. My own mother in Russia, as a 9-year-old, had malaria, and when I was growing up, she was telling me what that going up and down with those fevers and chills was like, and how much it made a difference. There was one doctor that had a bit of chloroquine for her, and so my fear, which I'm not going to ask you to comment on, is that ongoing violent conflicts is a great way to grow, it's a great medium for growth for these problems. But anyway, next.
Thank you so much for the lecture. That was very edifying. I just wanted to know, are you familiar with Oxytec's Just Add Water program? And I just wanted to get your opinion.
Just add water?
Yeah, it's like a carrying case with, you add water to, I think they're Wolbachia style. Yeah. Just wondering.
Vaguely. Not,
Yeah.
Yeah.
Okay, well, we could talk about it after, but yeah.
So I'm Gil Oman from University of Michigan. Thank you for such a comprehensive and impressive presentation and all the work you're doing. There was one critical piece in the early part of your lecture that I perseverated about, which was the need to inject individual male larvae. That sounds like a very big task. And what is the quantitative nature of introducing those changes or introducing gene drives? How many larvae, how many mosquitoes have to be handled and injected? And how does it actually work? I think when you go to the big social issues, some people may still be stuck trying to understand what it is the intervention.
Yes. So the initial mosquitoes that have to be injected, those numbers are not very high because you can have just a few thousand, and those can be reared into a colony of mosquitoes because we do crosses with the wild type mosquitoes. So each adult modified mosquito, for example, might have, say, 100, 200 eggs, and those will be modified offspring. So actually the biggest challenge with scaling up this technology is, well, we call it sexing, but that sounds weird to someone who is not in entomology, but basically separating the sexes of the pupae because we work with the male mosquitoes. So once you have your first offspring, you want to remove any females that might be in there and then keep working with the males. And if you're looking at female fertility, for example, you're only going to release ideally male mosquitoes that don't bite and that have a bit of a less nuisance factor. So that is actually the most labor intensive because you're going to release 10,000, like depending on the area you're going to go to, maybe 10,000, maybe 20,000. And this might be very frequent for the first few weeks, maybe, like you do it for a bit of the first few weeks or multiple areas. So for that, there is quite a bit of technology that's being developed. That's like automatic pupil sorters or larval sorters that will sex the pupae by themselves automatically. So you don't have to have a person behind a microscope going, that's a male, that's a female, which is a bit more labor intensive. So yes, for the scale up, there will need to be some of that technology functioning perfectly. So we are testing some of it already. Yeah.
Very good. If there's nobody else waiting, I would share one other comment. Zach emphasized this problem of doing things in developing countries that haven't already been done and accepted in the developed world. And I have an example of a very severe experience that might be relevant to that. Mm-hmm. This was the work of Dr. Jonas Salk, did important work on polio, of course, trying to apply the very same approach of killed virus vaccine to HIV. Mm. And it was a time when the big companies were all focused on the surface antigens, which turned out not to be a good strategy many years later. And what happened with the killed virus, HIV virus studies, is that all the immunological work, virological work was very promising. But when it came time to conduct the studies, not for profit, but to help the developing world, I was on the original board of this company called Immune Response Corporation. The reaction was very negative. Mm-hmm. Do it first in America. Mm-hmm. And at the same time came the triple therapy with drugs. And America, where it causes no consequence, at least for the companies, this was the method. It worked. Phase 2 of our studies was very good. Phase 3 trial was ready to roll, and it went forward. Mm. And the result was the comparison group for phase 3 had to be triple therapy. And with triple therapy, there were almost no deaths. The combined triple therapy plus the killed viral vaccine was no better than triple therapy alone. But that was not an option for the third world, certainly at that time. So the result was the company vanished, the technique vanished, and we are where we are still with millions of cases of HIV. So I'm desperately hoping this will be very much more successful and it won't rest on first finding people in the United States to treat for malaria.
Mm-hmm. Yes, so thank you so much. That's an excellent example of what happens if you don't have co-development, or what could happen. So they did phase 1, phase 2, phase 3, none of that in Africa. And then they wanted to go to Africa, and people said, what is that? No, we don't want it. So hesitant to comment when I don't know that much about the project, but I would say, could they have done part of phase 3 in partnership with some place in Africa? Phase 1 rather, phase 1 and phase 2, could they have involved the regulators at that level so that by the time they're asking them to regulate phase 3, they know what you're talking about and they know what safety studies you've done, and they're a bit more confident that they are not guinea pigs. Right. This is a constant concern in many third developing countries or within Africa especially. So it is a concern that you hear a lot, even when we're doing stakeholder engagement now. But the value of having people part of your development process, right when you're telling them what the problem is and why you're aiming to solve it and how, it's really invaluable because, again, like you just highlighted, the danger of working for years on your innovative solution, getting there, and then acceptability just isn't present. That's a big problem, and that's why stakeholder engagement remains one of the key arms for Target Malaria.
That's an excellent point. I share that point. In fact, even that was 1980s into the early 90s. Much earlier, in the 1970s, I was in the White House science staff, deputy science advisor, and sponsored a study at the National Academy of Medicine, now it's called, on clinical investigation in developing countries. And in 1978, the report recommended just exactly what you're saying now. Just didn't get implemented very much. Thanks.
Thank you.
We have time for one last question. It's a pleasure to hear your talk, and your work is incredibly inspiring. I wanted to ask if you could give advice to young students that are interested in global health in this part of the world. How should they approach working in Africa? How should they approach and think about engaging with local populations, with local stakeholders? If you have any advice on that, I think lots of several members of the audience would be interested.
Absolutely. So I think students from this part of the world, especially for now, still have the unique advantage of the fact that you can contribute just so much more, just because of the resources that are available, the kind of technology that you have access to. So it's great if you care about solving problems that affect people that are so far removed from yourself. That is fantastic. And my advice to everyone would always be to work with something you're passionate about, because it's said often that then the work is not really work. Not necessarily true, we work, but you enjoy your work. So there's just some satisfaction in doing something that means, something to somebody and means something to you. So my advice to those students would be that if you truly care about the people that, that you're trying to help, I would advise that it's important to meet some of those people. Take advantage of any, foreign trips that might be available, or some field research that might be available. It will inspire you so much more, but also means so much to the people that you're helping if you get an opportunity to interact with those people, to see what the issues are on the ground. Of course, some of the things you're developing you could do in a lab in the US and never once step there, but I think it will be very impactful to career development and just to general motivation if you are able to see the problem and the people that you're really making a difference to. So that would be some of my advice. If you truly care, it doesn't matter if you're very different or you go there, and even if you don't speak the language, I feel like love is just a communal language. If you care about people, they will know that you care. Yeah.
Hi, Luke Sagers. I'm representing the online audience, actually. So this question comes from Mimi Alcatan from HMS DBMI. And Mimi asks, can you speak more about building trust with local and regional communities when proposing molecular technologies for use in medicine and public health? Do you have a specific example that you can share?
Yes, I do have some specific examples that we can share. So because Target Malaria does work in actual local communities with people that may not quite understand the technology when you start out. So key among, if I could pick out just some key elements, the first thing is that you have to simplify the language when you're speaking to people that don't understand the technology at all. A lot of times as scientists, we show up and we make a nice, beautiful speech with words that 90% of your audience doesn't understand, and then you're like, oh, I explained it. So it's so much more than that. And a lot of times regulatory bodies, at least in Uganda, for example, our institutional regulatory body looks at that. They look at what you call the information sheets, What do they look like? Will the community understand them? So it's very important to find ways to simplify some of this technology. But also something that has been very useful to us is translating to the local languages, because we do that for the information sheets. We have translated into the local languages so that we can say it's truly informed consent. They didn't just say yes, they understood exactly what you were doing. So that has also been very key. But an example is, for example, in Burkina Faso, I did mention that we did a sterile male release. So that means we released a modified mosquito into a community, basically, like it was a community of people. And they approved that. The regulators approved that, which is great, but also the local people did approve that. So we did have a challenge with that. I think if you go online, it's probably, you'll probably find it if you Googled it, where there were some organizations that tried to claim that this is detrimental to the people, and the people didn't really approve it, and things like that. But when interviewed, they tried to interview the people, and the people stood up for the project. And they said, no, we understand what they're doing, and we can explain it, and we approve it, and we will not ask them to leave. They tried to get the village to ask us to leave. And they say no. Why? Because they understood it. So they couldn't be deceived. So it takes a little bit longer and maybe quite a bit more effort to make sure that people understand what you are doing, even without your background, and even though they're not scientists. But it's worth it, because that's the kind of difference it makes when it comes to implementation.
Thank you so much, Krystal. Really appreciate it.